In this video, I'm going to talk about solving systems of linear equations by elimination by addition. In the first part of this video, I explain how you can solve the system of equation graphically. But for this one, I'm going to show you the algebra method of solving for x and y. Okay, so let's go ahead and see the first example. Let's say we have this system of linear equation, x plus y equals 7. The second equation is x minus y is equal to 3. So we're going to start with this very simple and easy system of linear equation. So basically, the idea here is we're going to look for x and y values, and those values have to satisfy these two equations. So when you look at the first equation, you're actually looking for two numbers when you add give you 7. It's going to be 5 and 2. 5 plus 2 is equal to 7. Now, those two numbers also satisfy the second equation. 5 minus 2 is equal to 3. Now, in the first part of the video, we actually solved this system graphically, and the solutions that we got are 5 and 2. Okay, and the 5, 2 represents the coordinates of the intersection of those two lines. Because x plus y equals 7 and x minus y equals 3, they actually are linear equations whose graphs are straight lines. So those are two intersecting lines, and the point of intersection represents the solution, 5, 2. Okay? And by algebra, we expect to see something like x is equal to 5 and y is equal to 2. So basically, that's the xy ordered pair. X is 5, y is 2. Okay, so the process of elimination by addition is very straightforward. So this one is so easy. You can see that the y's are already opposite in sign. So the first thing you check is whether the x terms are lined up correctly. So is the y and constant. Okay, so we have this organized already so that we can add them readily. Now the plus y and the minus 1y are going to be eliminated when we add the two equations. So the 1y and the minus 1y is going to be 0y. Now this x plus x is going to be equal to 2x, which is 10. Okay, the 0y is just 0. So we're left with this 2x is equal to 10. And then when we divide both sides by 2, x is equal to 5. So this is done by elimination by adding the equations. Okay, so we can just plug in or substitute the x is equal to 5 to one of those two original equations. So you can pick, you think the one is simpler. I'm going to use the first equation, x plus y is equal to 7. And then I'm going to plug in this 5 to x. In that way, I can solve for y. Okay, so 5's are cancelled. Now we have, y is equal to 2. 7 minus 5 is equal to 2. All right, so let's look at the second example. Say we have 2x plus 3y is equal to 18. And then 2x, say minus 2y is equal to 2. Now in this example, we again go back to the idea that we have to eliminate one of the variables so that we can solve for the other variable. So when you look at the equation, the y terms, they have opposite in sign, but the coefficients are not the same. So one is 3, the other is 2. So we cannot immediately, eliminate the y terms. Now, the x terms, they have the same coefficient. In other words, if you add it, it's going to be 4x. It's not going to be eliminated. So what we can do in this case is we can multiply either the first or the second equation by a -1. Okay, so you're allowed to multiply the entire equation by a number. Now, when you multiply the second equation by -1, so we're going to leave the first equation alone. So it will stay the same, 2x plus 3y is equal to 18. Now, the second equation, after you multiply by -1, becomes -2x. Now, the -2y, so negative times -2y is now a positive 2y. Now equals -1 times 2 is -2. Okay, so when you look at this 2x and -2x, they're canceled out. And then the 3y plus 2y is 5y is equal to 18 minus 2 is now 16. Okay, so we can divide by 5. So y is equal to 16 over 5. Okay, let's go back to our original equation. Now, the first example, we use the substitution to get the other variable, to get the other solution. Now, we can plug in or substitute this y to one of those two original equations, but the thing is, it's a fraction, okay? So, if you want to not operate with this fraction and you don't want to use the substitution, you can do the process of elimination again, like for the second time. So what we do is go back to our original two equation and find a way to eliminate the x, or eliminate the y this time. Eliminate the y this time so you can get the x. Now, how do we get these y's eliminated? So you can think about making these numbers the same, but opposite in sign, of course. So think of numbers 3 and 2. What is the least common multiple of 3 and 2? So the least common multiple, meaning when you skip count by 3, like 3, 6, 9, 12, and then you skip count by 2, 2, 4, 6. So what is the first match? 3, 6, 2, 4, 6. So the first match is the common multiple, which is the least common multiple. So this is the number you want this 3 and 2 to become. Okay? So in other words, you're going to find a number to multiply to 3 to give you that 6, and that's a 2. Okay? Because again, 2 times 3 is this 6 right here. Now, for -2, what number you're going to multiply this 2? Okay, so what number you're going to multiply this 2 to give you that same number 6? So it's a 3. Okay? So let's rewrite the equations. Now we have 4x plus 6y is equal to 36. And then the second equation is 6x minus 6y is equal to 6. Okay, now the y's are canceled. You got 10x is equal to 42. Okay, now you divide by 10. So your x is equal to 42 over 10, or when you reduce it by 2, you have 21 over 5. Okay, so those are our solutions. It's a little tedious because both values of x and y are fraction. Okay, let's do one more example. Say you have 2x plus 3y is equal to 18. Say 3x plus 4y is equal to 25. Okay, so we can decide which term you want to eliminate. At this point, when you combine the two equations and try to add the x terms, you're going to get 5x, 7y. In other words, none of them is eliminated. So we cannot immediately combine the equation. So what we do is decide, okay, which variables you want to eliminate first. If you decide to eliminate the x first, then we're going to get the y value, okay? So let's eliminate the x first. So what is the LCM of 2 and 3? Again, skip count by 2. 2, 4, 6. Skip count by 3. 3, 6. So the first match is the common multiple or the least common multiple, 6. Okay, so we're going to multiply this 2 by 3 to get that 6. Now, same with this 3, okay? Think of a number to multiply to 3 to give you 6. Now, if you multiply 3 by 2, you get a 6. Multiply 2 and 3, you get a 6. Okay, in order to eliminate them, they have to be opposite in sign. So you want to make one of them negative. All right, so let's go ahead and multiply the first by 3. So you got 6x plus 9y is equal to 54. Now the second equation multiplied by negative 2 is negative 6x, negative 8y is equal to negative 50. Okay, now, as you can see, the x terms are cancelled out. 9y minus 8y is 1y, or simply y. And then 54 minus 50 is a 4. Okay, since we have this integer as our y value, it's easy to plug in that number to one of these two original equations. So pick the one that you think is simpler. Okay, so I think the first one is simpler, so I'm going to use that, okay, to plug in my y. 2x plus 3 times y, which is a 4, is 18. Okay, 2x plus 12 is equal to 18. So I'm going to go ahead and take away the 12 from both sides. Now I have 2x is equal to 6. And then divide by 2. X is 3. Okay, so 2 is cancelled. Then you have 6 over 2, which is 3. So my solution is x3. Okay. Quickly, graphically, the solution x equals 3 and y equals 4. Okay, so that solution 3, 4 represents the point of intersection between the lines. Okay, and those lines are represented by the equations provided given to us. Okay, so hopefully this video helped, and thanks so much for watching. Until next time.